Here we go, we got to lesson 2.6. Here we're applying what we've learned in the previous lessons, sine, cos, and tan. So in any given right-angled triangle, we can use the trigonometric ratios to solve the entire triangle. And that's kind of the important part of today's lesson. If I give you a triangle and I ask you to solve it, well, what does that mean? If you think about a triangle, we have got three sides, and we've also got three angles. So if I ask you to solve this triangle, I want you to give the measure of all three sides and all three angles. Now usually when you have a trig question, some of this is already given for you. So you'll have to just identify what are the lengths of all three sides, what are the degrees of all the angles. So the question here now is, which of the ratios do I use? Up until now, the whole lesson has been on either the tan, or the sine, or the cos. Now we're going to mix everything up for you. You need to figure out which one do I use. Luckily, there's a little bit of a memory device we can use. SOHCAHTOA. So SOHCAHTOA is a term that anybody familiar with trigonometry will know. SOHCAHTOA is going to be your best friend in helping you figure out which one to use. Problem is, you have to spell it right. The first three letters, SAW, well, that sine is opposite over hypotenuse. Next three is the CA. Cos is adjacent over hypotenuse. And the last part is TOA. Tan is opposite over adjacent. So if you write this down on your worksheet, the first thing, SOHCAHTOA, spell it right, then you've definitely got the starting of sine, cos, and tan. So let's look at what a question typically looks like here. Solve this triangle. Okay, well, we have a triangle. We know this is 7. We know the angle is 35. And of course, we know this angle here is 90. Well, the first thing we've got to do is give the vertices of our triangle letters. So I'm just going to call this A, capital A. I'm going to call this capital B, and capital C. So now if I call the angles with capital letters, my sides are going to be called with lowercase letters. So this side here, across from the angle A, is lowercase a. This side here, across from the capital C, is lowercase c. And this side here, across from the angle B, is lowercase b. So we kind of see that in math, uppercases we use for angles, lowercases we use for sides. So the question does say solve. So I want to know what are my three angles and what are my three sides. So let's list them here. I've got angle A, angle B, and angle C. Capitals, I've also got side A, side B, and side C. So let's look here. What do I already know from my triangle? Well, I know that the little c, which is a side, is 7. So I'll fill this in right here. Little c was 7. I also know angle A to be 35. 35 degrees. And I know one more, and it might be hidden, you might not recognize it, but this square on an angle means 90 degrees. So angle C is 90 degrees. So I've got 3 of my 6 given to me. I got to solve for the other 3. So here's where trigonometry comes in. I'm going to start with angle B. I'm going to switch to a green color here. Angle B. Well, you may remember from previous grades that if you take the angles of a triangle, they have to add up to 180. So I'm going to take that idea of 180 and I'm going to subtract my 2 other angles. I'm going to minus the 35 and I'm going to minus the 90 degrees. So 180 minus 35 minus 50 will give me my last angle. And in this case, if you do the math, we've got 55 degrees. So angle B is 55 degrees. So now let's solve for side A. I'm going to go to a red marker here. Okay, so if I am looking for side A, first thing I do in trigonometry is label my triangle. Well, what angle do I know? Well, this is the 35. So if this 35 is the one I know, I start labeling opposite, adjacent, hypotenuse. I start with my 35, I go across the triangle, here's my opposite. I find that 90, go across the triangle, it's my hypotenuse. And then the other side, touching the angle, will be the adjacent. So let's see. SOHCAHTOA. Write that out up here for a sec. Saw, ka, toa. Which formula am I going to use? So I ask myself, what am I looking for? Well, I'm looking for the opposite. And which one do I know? I know the hypotenuse is 7. I know nothing about the adjacent, so I can't use it. So in order to solve for angle A, or side A, I need to use the opposite, the O, and the hypotenuse, the H. Well, which one of these has the O and the H? Well, it's sine. Sine is opposite over hypotenuse. And I knew that because I went, what am I looking for? What side do I know? So I wrote the formula. Sine of the angle equals the opposite over the hypotenuse. Now I'm going to plug in what I know. I know the angle to be 35. Sine of 35 equals the opposite. I don't know what that is. I'll change to an x over 7. So now I think, okay, what math could I do? Well, I can do the sine of 35. To do that, I go to my calculator. So I'm going to bring up Desmos. Just like before, I'm going to type Desmos into my search bar. And here it comes up. I'm going to pull up my scientific calculator. And for Desmos, I type in my function first, which is sine, and then my angle, which is 35. And my answer is 0.57 through a bunch of different numbers. Trigonometry, we're going to go to 4 decimal places. So 0.573, and then my next number is 5. But I got to round properly. So I go to the 7, and the 7 rounds up. So I go to 0.5736. Slide my work down here a little bit. Sine of 35 was 0.5736 equals x divided by 7. Now all I have to do is isolate the x. It's being divided, so I'm going to times each side by 7. And my final answer, rounded to 1 decimal place, will give me 4.0, or just 4. So now I know the length of side A. I'll come back up, and I'll fill out side A to be 4. Now my only piece I don't know is side B, so I'm going to change to a blue, and I'm going to look for B. Now again, I've got the angle 35. It's labeled properly, opposite, hypotenuse, adjacent. But now if I'm looking for B, I need the adjacent, the A, and then I have some options. I know the opposite is 4. I know the hypotenuse is 7. So I could choose either of those numbers to use. Personally, I'm going to go with the hypotenuse, just because the 7 was actually given to me. If I had made a mistake in calculating 4, then I'd be making a second mistake when calculating the adjacent. So I'm going to go with the number that is given. I know it's 100% right. So the adjacent and the hypotenuse, A and H. Which one has the A and the H? Well, that is the cos. Cos is adjacent over hypotenuse. Start by writing out the formula. Cos of the angle equals the adjacent over hypotenuse. I'm going to plug in what I know. Well, I know the angle is 35. My adjacent I don't know. I'm going to leave that as an x over 7. Okay, so I do the math that I can do, which is cos of 35. I'm going to go back to Desmos. I'm going to clear it, and I'm going to write in the function of cos, and the angle is 35. And here my answer is 0.8191. And then I'm going to round that to a 2 because we have a 5 as the next digit. So 8192 is what I'm going to use. I write that out. 0.8192 equals x over 7. And now same idea, I'm going to isolate the x by timesing each side by 7. That's going to cancel out, and my x to one decimal place will be 5.7. So now I can fill in my chart at 5.7. I now know all 3 sides and all 3 angles. Okay, let's flip our page. We've got one more question to look at. Solve for the question mark. Okay. So now you'll notice here that we don't have any sides or any angles. We know this is 2, we know this is 4. So you got to think we're going to use every tool we can in order to solve. And in this case, you might recognize this as Pythagoras. A squared plus b squared equals c squared. Right angle triangle, we're going to label it A, B, and C. Well, my 2 legs are A and B, and my hypotenuse is C. Let's plug in what I know. 2 squared plus 4 squared equals c squared. 2 squared, that's 2 times 2, which is 4, plus 4 squared, which is 4 times 4, which is 16. And that'll be c squared. I'm going to add these together. 4 and 16 is 20. And we see that equals c squared. And don't get confused here, we're not done. We're looking for plain old c, not c squared. So I've got 20 in my calculator. I hit the square root button, and to one decimal place, rounded correctly, I get 4.5. My unit here must be centimeters, because everything else is in centimeters. 4.5 centimeters is c. So I know the A, I know the B, I know the C to be 4.5. So the question mark, trig didn't work, but we have other tools that are methods. We've got Pythagoras, a squared plus b squared equals c squared. Now just for fun, let's solve the actual triangle. So I know this isn't part of the question, but we'll do it anyway. We know all three sides, 2, 4, and 4.5. We know this angle here. Well, that's 90. But what we're looking for is this angle and this angle. So let's give it some names. Capital A's, B's, and C's. Well, this is side A. This must be big A. If this is side B, this must be big B. And if this is side C, then this must be big C. So the question is, what do you want to look for first? Do you want to look for A or B? Let's do angle B. So if I'm looking for angle B, which will be written in red here, we start by doing opposite, adjacent, and hypotenuse. Going across the angle is the opposite. Beside the angle is adjacent. And hypotenuse. So we gotta choose. And is it sine, cos, or tan? Because we know all these, we can choose any one we want. Let's go with tan. So tan of the angle equals my opposite over the adjacent. So I don't know the angle, so I'll just simply have tan of the angle. My opposite I know is 4. My adjacent I know is 2. So now let's figure this out. We have got 4 divided by 2, which is 2. Tan of the angle equals 2. So I can't do any more math here, but I can figure out the angle. Right now it's being multiplied by tan. Well, what's the opposite of tan? Well, it's the inverse tan. Tan to the negative 1. So I go to Desmos. And I'm going to change my sine, cos, and tan using the second function. So for Desmos, it's the function button. Look what happened. Now I got sine to the negative 1, cos to the negative 1, and tan to the negative 1. So I click the tan to the negative 1. I go back so I can type in some numbers here. And my number was 2. 4 divided by 2 is 2. Well, not 22, but plain old 2. You see my angle here is 63.43. For angles, we'll go to 1 decimal place. So I can say 63.4. I come back and say the angle is 63.4, which I can put up here, 63.4. Now all I gotta do is find my other angle. And I can use trigonometry if I wanted to, but I really think I'm going to work a little easier here. I know that angle A is going to be 180 minus the 90, which is angle C, and minus the 63.4, which is my angle B. Go to my calculator, 180 minus 90 minus 63.4, and that's going to be 26.6 degrees. And now I've solved 26.6. Multiple ways you can do it. Sakatoa is going to be your friend, but when you asked for solving a triangle, you got to give me 3 angles and 3 sides. If we go to our textbook, we can work on page 111, 2 from the A's, 5 from the B's, one from the C's.